Auditory seasoning filters, altering food perception via augmented sonic feedback of chewing sounds. Be aware that this presentation contains some chewing and eating sounds. If you experience misophonia, please mute the sound of this video. The experience of eating is shared daily among most humans as a social, cultural, pleasurable, and life-sustaining activity. A crucial part of body weight management, healthy eating involves consideration both in terms of food choices, such as avoiding excess intake of salt, sugar, and fat, as well as eating practices, including eating the right quantity of food, eating at a slower rate, and increasing the number of chews before swallowing. When we eat, our experience of the food isn't only dictated by our taste bud, but also by other senses. Perception research has demonstrated the important role of visual, olfactory, and tactile cues that can affect our perception of what we eat in terms of texture, flavor, and sense of fullness. The HCI community has leveraged these findings to create tools for healthy eating, but they often require cumbersome external hardware or the use of especially produced food. These issues reduce the adoption factor of the technology and limit their potential as just-in-time interventions. Therefore, the question arises, how can we design easily deployable, scalable, and ubiquitous interventions that can help users regulate their eating behavior in real time without solely being based on deliberate self-control? Could the food itself tell us what to eat and when to stop? Inspired by cross-modal research on sound and food perception, combined with recent work on modulated auditory feedback, we explore how changing the way we hear our own eating sound can affect perception of food texture, flavor, and eating experience. Although previous literature has demonstrated the undeniable links between sound and food perception, these works have often focused on single experiential aspects, such as flavor or texture, and have included, for the most part, external auditory stimuli, such as background music. Closed-loop modified auditory feedback has been shown to have strong subconscious neurological effect during various behavioral tasks, including speaking, by affecting fluency and motor control, singing, by influencing pitch and prosody, as well as breathing and eating. Previous work in the context of food has shown that applying a high-pass filter on chewing sound in real time has been associated with a high sense of crunchiness and freshness in foods. Our work takes a broader view on how modulating food-intrinsic auditory feedback parameters can influence different aspects of eating beyond flavor, such as deliciousness, craving, fullness, and eating speed. The purpose of this work is to introduce and evaluate the potential of auditory seasoning filters, meaning changing auditory feedback of chewing sound in real time while eating, in influencing eating behavior and flavor perception. We created various auditory seasoning filters and tested them in a Pringle eating experiment. We ran a mobile-based study on 37 participants to evaluate the self-reported effects on eating experience. More information about the ethics, protocol, and auditory mode implementation is available in our paper. Our results suggest that amplifying eating sound increases all food texture and flavor-related parameters: crispiness, saltiness, sourness, mouthfeeling, and overall flavor intensity. Louder eating sound also led the participant reporting feeling more full. For delays, we did not observe any effect on perceived texture or flavor. Comments suggest a decrease in eating speed. Moreover, participants reported out-of-body experiences where they felt like they were eating with someone else, or that the chips tasted less flavorful. Large room reverb made the chips taste less sour and led to less craving. Satiety may be linked with primitive reactions to environmental incongruence, leading to a more alert behavior less prone to eating, or to a more culturally informed restrained behavior in large room where one can be observed and therefore is more self-conscious. Low-pass filter led to less crispiness, more mouth-filling texture, and more fullness after eating. Interestingly, both high and low-pass filters led to more fullness, which suggests that fullness may be mediated by attention to the food. Although less suited for social eating, such a tool would be most relevant in situations where people already eat while listening to video or music, as they are less attentive to their own eating sound. Potential applications include interactive tool for flavor enhancement, more mindful and slower eating, educational activities for children to increase food diversity, high gastronomy experiences in restaurants for augmented, curated fine dining, or just-in-time interventions based on chewing detection for eating disorder support. Auditory seasoning filters lay the groundwork for developing audio-based mobile interventions to regulate food perception and cravings without the need for additional devices or deliberate explicit self-regulation.